kids. In an attempt to help you understand the meaning of the wave-particle duality experiment, this is a reading from The Dancing Woolly Masters by Gary Zukav, and it explains how physics tries to make sense out of this really crazy situation we find ourselves in with wave-particle duality. And this is a couple of the interpretations of that new reality we find ourselves in. These are not science fiction. These are some ideas. So, Schrodinger's cat sums up the differences between classical physics, the Copenhagen interpretation of quantum mechanics, and the many worlds interpretation of quantum mechanics. Schrodinger's cat is a dilemma posed long ago by the famous discoverer of the Schrodinger wave equation. A cat is placed inside a box. Inside the box is a device which can release a gas, instantly killing the cat. A random event, the radioactive decay of an atom, determines whether the gas is released or not. There is no way of knowing, outside of looking into the box, what happens inside it. The box is sealed and the experiment is activated. A moment later, the gas has either been released or has not been released. The question is, without looking, what has happened inside the box? Well, according to classical physics, the cat is either dead or it is not dead. All we have to do is open the box and see which is the case. According to quantum mechanics, this situation is not so simple. The Copenhagen interpretation of quantum mechanics says that the cat is in a kind of limbo represented by a wave function, which contains the possibility that the cat is dead and also the possibility that the cat is alive. When we look in the box and not before, one of these possibilities actualizes and the other vanishes. This is known as the collapse of the wave function, because the hump in the wave function representing the possibility that did not occur collapses. It is necessary to look into the box before either possibility can occur. Until then, there is only a wave function. Of course, this does not make sense. Experience tells us that a cat is what we put into the box, and a cat is still what is inside the box, not a wave function. The only question is whether the cat is a live cat or a dead cat. But a cat is there whether we look at it or not. If we take a vacation before we look inside the box, it makes no difference as far as the cat is concerned. Its fate was decided at the beginning of the experiment. This common-sense view is also the view of classical physics. According to classical physics, we get to know something by observing it. According to quantum physics, it isn't there until we do observe it. Therefore, the fate of the cat is not determined until we look inside the box. The many worlds interpretation of quantum mechanics and the Copenhagen interpretation of quantum mechanics agree that the fate of the cat is not determined for us until we look inside the box. What happens after we look inside the box, however, depends on which interpretation we choose to follow. According to the Copenhagen interpretation, at the instant we look inside the box, one of the possibilities contained in the wave function representing the cat actualizes and the other vanishes. The cat is either dead or alive. According to the many worlds interpretation, at the instant that the atom decays, or doesn't decay, depending on which branch of reality we're talking about, the world splits into two branches, each with a different edition of the cat. The wave function representing the cat does not collapse. The cat is both dead and alive. At the instant that we look into the box, our wave function also splits into two branches, one associated with a branch of reality in which the cat is dead, and one associated with a branch of reality in which the cat is alive. Neither consciousness is aware of the other. In short, classical physics says there is one world, it is as it appears, and this is it. Quantum physics allows us to entertain the possibility that this is not so. The Copenhagen interpretation of quantum mechanics eschews or rejects a description of what the world is really like, but concludes that whatever it is like, it is not substantive in the usual sense. The many worlds interpretation of quantum mechanics says that different editions of us live in many worlds simultaneously, an uncountable number of them, and all of them are real. There are even more interpretations of quantum mechanics, but all of them are weird in some way. Quantum physics is stranger than science fiction. This is kind of where we're at. So it lends a different ending to if a tree falls in the forest and nobody's there to hear it, does it make a sound? According to quantum physics, if a tree falls in the forest and nobody's there to see it, there's no forest. Good luck with that.